Hello Internet, Zach here, and welcome back to Collecting the Elements. In this, the final episode of the year, I've acquired a sample of my favorite metal from a local supplier. This is a metal that I first encountered during my junior year of high school on a trip to the Maryland Renaissance Fair. I happened upon this wonderful jewelry store called Sozra. Alongside the usual gold and silver jewelry, there was also this strange, wonderful, multicolor metal. I was intrigued. What on earth is this? I learned the metal is called niobium, and the colors are caused by a thin layer of oxides, in exactly the same way that titanium gets its colors. So I'm going to show you in this episode how to add colors to niobium in exactly the same way that I did with titanium. You'll get to see that the colors show up even brighter, they're more vivid, it's more fun. Anyway, niobium isn't just used in jewelry, although the sample I acquired was yet another piece of jewelry. Niobium is also used in high-tech, high-strength alloys, and as a compound with tin is used in superconducting magnets. Now, niobium gets its name because it was discovered in tantalum ore, so it was named after the daughter of Tantalus, Niobe. Niobium would, if not given anodized colors, just be an ordinary soft silvery gray metal with a very high melting point of 2500 Celsius or 4500 Fahrenheit. I'm not going to be melting this with my propane torch. It's just not going to get hot enough. So let's bring the year to a colorful close, shall we? The first step is going to be to take the oxide off of the niobium. To do that, I have a Dremel with a Q-tip, well, because I can't afford to get a proper polishing wheel right now. And I have this amazing polishing paste. I've had this tube of polishing paste for 16 years. So a little polishing paste on the Q-tip, and I'm going to carefully polish off the oxide layer off of the niobium. Now remember, when playing with rotary tools, have your safety glasses. And without the layer of oxides, niobium just looks like a plain silver metal. Since this ring is too big to fit into a test tube, I'm going to unbend it, and to do that without marring the metal, I'm going to take these pliers here, slip on these two pieces of plastic aquarium airline tubing, use that to grip the ring, hopefully there we go. Unbend it. Well, it's kind of unfortunate. I did manage to mar up the metal a little bit. The good news is, it'll fit in the test tube now. Now I thought I saw some bits of color still on here, so means a little more polishing is in order. So I want to make sure the metal surface is completely free of old oxides before I recolor it. That's better. Alright, in here is a solution of Epsom salt, which is magnesium sulfate, with a couple drops of hydrochloric acid stirred in, which makes a solution that contains very dilute sulfuric acid, which is what actually does the anodizing magic. So we're going to start with one 9-volt battery here, and dip the niobium into the solution. Not much of a color change at 9 volts, but I wasn't expecting there to be. The fun usually starts at about 18 to 27 volts. And at 27 volts is when things get interesting. .36 volts. 45 volts. 54 volts. 63, 72, 81, 90, 99, 108, 117, see if I can catch the light right. So now you have over the surface of the metal from 9 volts here, well, actually from about 27 volts here up to 126 volts on this end. And that is reactive metal anodizing of niobium. And there it is, niobium, the 16th element in my table. and the last one for the year. I hope you all enjoyed this. If you did, hit the like button. If you know someone else who might like it, hit the share button. And if you'd like to see more, hit subscribe. As always, don't be afraid to leave comments. And I'll see you next year.